Hey class, today we're going to go ahead and start 2.2, and we're looking at strategies for solving word problems and using linear equations to solve word problems, but you have to build the linear equation from a word problem. So let's go ahead and jump into it. So first I'm going to start off by giving you some strategies for solving word problems. So one strategy is that you're going to need to read it carefully. And the only reason I put this on here is because sometimes when students tell me to help them, they haven't read the problem yet. So start off by reading it. Read it carefully, think about it. Second strategy, you want to assign some unknowns, some variables for your unknowns, and define them if possible. So usually you could call one of them X. If there's only one, you could just say it's X. If there's another one, say it's Y. If there's another one, call it Z. Or you could call them any letters you want. I've seen students assign different letters and the problem works out just as fine. Strategy 3, write the equation modeling problem. So this is probably a more difficult one, but we're going to do a bunch of practice problems, and hopefully that'll help you. You'll get some of the idea of how it's done. Okay, number 4, you want to also solve the equation. Sometimes it doesn't ask you to, but when it does, make sure you do that. And then the 5th strategy, check your solution. And that's it. So these are the strategies I have for you guys. Now here, I'm going to write down some words that are commonly used for these operations. So we have addition, subtraction, division, and multiplication. And we'll just write some common words in word problems that signify that you're supposed to use this operation. So for addition, you could have words like more than, increase, sum, added to, or exceed. Exceeds by. So these are words that usually signify you're going to need to add. What about subtract? Words like less than, although you need to be careful with this one, and I'll explain more as we go. Decrease, difference, and subtracted from. That one's pretty straightforward. All right, what about division? If you see the word quotient, definitely you're going to have to divide. And divided by. There's more, but I'll leave it there because I want to try to keep this video brief. And our last one, multiplication. If you have the word of, multiplied by, times, or also the product. And I'm going to add one more symbol in here. These are our operations, but there's one symbol that's not an operation. It's an equal sign. And I think some words that mean equals is like is, or are, or will be, or those kind of words. Okay, so let's go ahead and jump right in. We have a few examples, and we'll just jump right into these now. So the first example. When 2 times a number is decreased by 3, the result is 11. Maybe I'll go back here and put result. That's another one I didn't put down for equal sign. So it says, what is that number? Before we can find out what the number is, we're going to go ahead and assign unknowns, and we're going to write the equation. So taking a look here, it says, when 2 times... And we already said when we see that, that's going to be multiplication. So I'm going to put 2 times a number. So since we don't know what the number there is they're talking about, that's when you assign an unknown. So I'll use an X. So 2 times a number is decreased by 3. So minus 3. And I don't have to put parentheses because multiplication is before subtraction. But if you want to put parentheses right here, showing that you need to multiply by 2 first, then decrease by 3, if you like to, you can. So just remember when you're reading the problem, what happened first, what happened second, and what they're asking. Luckily, multiplication comes before subtraction in PEMDAS, so if we don't put these parentheses, that's okay. And then it says the result is, that's an equal sign, 11. So we just read through, and every time we see a word, we plug in some kind of variable or number or operation for it. Now we can answer the actual question, what is that number? So we'll just use our solving for x algebra abilities and solve for x. So we'll put plus 3, these cancel, we're left with x, 2x equals 14, divide by 2 on both sides, and we'll end up with x equals 7. Okay, and then we could check the solution by plugging it into our original equation. If I multiply this number by 2, I get 14. And then if I subtract 3 from that, I'll get 11. So that means it checks out. And I won't do that in all the problems in this video, but I just wanted to point that out there. Checking your answer is important as well. Okay, so let's take a look at the second example. When a number, okay, I don't know what the number is, so I'm going to go ahead and assign a variable, is decreased by 30%. Now, in order to decrease something by 30%, you can subtract 0.3 times that number. So if you do 0.3 times that number, that's 30% of this number. So then if I subtract 30% of that, this is 30% of x, and I'm subtracting it from x. So that's how you do that. And then it says the result is 28. So we know the result is an equal sign, and then we put in 28 here. It says, what is that number? So now we have to solve for x. Now, some students may remember this, some don't, but there is a number in front of x here. It's not written usually, but if you want to write it, you can. It's a 1. Why is that important? Because we could subtract these two. These are like terms. So what is 1 minus 0.3? 1 minus 0.3 is 0.7. And we need to do that so we can get x by itself. So we had to combine these two x's together into, so there's only one x here. And then we can divide by 0.7. And we'll have x equals, so right here, if you have, okay, so we have 28 divided by 0.7. If I move the decimal once over here, that's kind of like I multiply this one by 10. And I can multiply this one by 10 also, if I multiply both of them. So that'd be 280 divided by 7. 280 divided by 7 is 40. So 28 divided by 0.7 is also 40. So that's one way you can do that in your head. So example 3, it says when 80% is added to the number, the result is 252. So now I want to take 80% of a number. I don't know what the number is, so I'll assign a variable. This is 80% of a number. Now I have to add this to the number itself. So I'm going to put plus x itself. And the result is 252. So it's similar to the last problem. So I could add these together, and I'll get 1.8. Because remember, there's a 1 in front of that x there. Then I'll have to divide 252 by 1.8. So if I divide both sides by 1.8, these will cancel. I'll left with x. Divide this side by 1.8. And I'll be left with 140. Okay, so let's take a look at our next few examples here. So it says, our next problem says, 70% of what number is 252? So here's 70% of a number, and they want to know when is it equal to 252. So this is basically, I just need to divide by 0.7 on both sides. So if you divide this by 0.7, you'll end up with 360. And that's it. That was a pretty fast one. Our next example says one number, I'll call it x, exceeds another by 24. Now this is important because a lot of the rest of the examples are like this. But it seems like I have to add 24 to this one. Oh, by the way, another number, we'll assign that letter y. So it says equals y. So when will these two numbers be equal? Well, let's say this is the bigger one. If this number exceeds this one, and I want these two sides to be equal, then I would have to add the 24 to this one. Because the y is smaller. So if I add 24 to it, then it will be equal to x. So a lot of students would see, the way it's written, they would think to themselves, one number exceeds another, oh, then I need to add 24 to this. But it's already bigger. So in order to make it equal to the smaller number, I need to add 24 to the smaller number, and then it will be equal in size to the first number. Okay? So, now we'll take a look at this. So we'll say, okay, let's let this be, so if you, the next sentence here, it says, if you add these two numbers together, the sum of the number is 58. So if I say x plus y equals 58, so basically I'm saying this is my x over here. Because we said x is equal to this. And if I add these two numbers, it equals 58. So I'm going to substitute y plus 24 in here because it equals x. So whenever I see an x, I can replace it with y plus 24. So I'll say y plus 24 plus 4 plus y, So I plugged in a y plus, you could put parentheses if you want. So this is where x used to be, plus y equals 58. Okay, so I can add the two y's together. That'll give me 22y. I'm going to subtract 24 from both sides. Okay, so this will be 34. And then I'll divide by 2 on both sides, and I'll get 17, I believe. So y equals 17. Okay, so our next example, it gives us two functions, and then it says the output of f exceeds those of g by 3. So if I have f and I have g, and I want them to be equal, which one are bigger? Well, f is bigger. So the outputs of g, we need to add 3 to those, and then they'll be equal. So now I'm going to go ahead and plug in what those functions are for f and g. So I'm going to put 10x plus 6 is equal to 12x minus 7. And then we'll go ahead and add on that plus 3 at the end. Okay, so now we're going to solve for x. So one thing we could do here, we can say, okay, I'm going to subtract 12x from this side and subtract 12x from this side. So these will cancel. And I'll be left with negative 2x. Now I want to move this 6 to the other side. So first I'm going to combine these together to see what the number is. That'll give me negative 4. So I'm going to have a negative 4 here. And then I'm going to subtract 6 from this side and subtract 6 from this side. So what's negative 4 minus 6? Give me negative 10. So I moved all the x's to the left and move all the numbers that don't have an x to the right. Now I'm going to divide by negative 2 on both sides. These will cancel. I'll be left with x. And my final answer will be x equals 5. Alright guys, I'm going to leave this last example, and we'll do that as a warm-up problem. Alright, that'll be it, and I'll see you in the next one, guys.